Hey, hi everyone, welcome back to this video series on Windows Server 2012. Hyper-V is a server role in Windows Server 2012 R2 that allows you to virtualize your environment and therefore run multiple virtual operating system instances simultaneously on a physical server. This not only helps you to improve server virtualization, but also helps you to create a more cost-effective and dynamic system. In this chapter, you will learn the basic concepts and features of Hyper-V that a Windows Server 2012 R2 technical specialist must know. You will also get a solid understanding of what is important in virtualization and in what areas of your work life you can use it. What is virtualization? Virtualization is a method of abstracting physical resources from the way that they interact with other resources. For example, if you abstract the physical hardware from the operating system, you get the benefit of being able to move the operating system between different physical systems. This is called server virtualization, but there are also other forms of virtualization available, such as presentation virtualization, desktop virtualization, and application virtualization. I will now briefly explain the differences between these forms of virtualization. Server virtualization. This basically enables multiple servers to run on the same physical server. Hyper-V is a server virtualization tool that allows you to move physical machines to virtual machines and manage them on a few physical servers. Thus, you will be able to consolidate physical servers. Presentation virtualization. When you use presentation virtualization, your applications run on a different computer and only the screen information is transferred to your computer. An example of presentation virtualization is Microsoft Remote Desktop Services in Windows Server 2012 R2. Desktop virtualization provides you with a virtual machine on your desktop. Comparable to server virtualization, you run your complete operating system and applications in a virtual machine so that your local physical machine just needs to run a very basic operating system. An example of this form of virtualization is Microsoft Virtual PC. Application virtualization helps prevent conflicts between applications on the same PC. Thus, it helps you to isolate the application running environment from the operating system installation requirements by creating application-specific copies of all shared resources. It also helps reduce application-to-application incompatibility and testing needs. An example of an application virtualization tool is Microsoft Application Virtualization App-V. Hyper-V features. As a lead into the virtualization topic and Hyper-V, I will start with the latest key features followed by a list of supported guest operating systems. This should provide you with a quick high-level view of this feature before you dig deeper into the technology. Key features of Hyper-V. The following are the key features of Hyper-V. New architecture. The hypervisor-based architecture, which has a 64-bit microkernel, provides a new array of device support as well as performance and security improvements. Operating system support. Both 32-bit and 64-bit operating systems can run simultaneously in Hyper-V. Also, different platforms like Windows, Linux, and others are supported. Support for Symmetric multiprocessors. Support for up to 64 processors in a virtual machine environment provides you with the ability to run applications as well as multiple virtual machines faster. Network load balancing. Hyper-V provides support for Windows Network Load Balancing (NLB) to balance the network load across virtual machines on different servers. New hardware architecture. Hyper-V's new architecture provides improved utilization resources such as networking and disks. Quick migration. Hyper-V quick migration feature provides you with the functionality to run virtual machines in a clustered environment with switchover capabilities when there is a failure. Thus, you can reduce downtime and achieve higher availability of your virtual machines. Virtual machine snapshot. You can take snapshots of running virtual machines, which provides you with the capability to recover to any previous virtual machine snapshot state quickly and easily. Resource metering. Hyper-V resource metering allows an organization to track usage within the business departments. It allows an organization to create a usage-based billing solution that adjusts to the provider's business model and strategy. Scripting. Using the Windows Management Instrumentation WMI interfaces and APIs, you can easily build custom scripts to automate processes in your virtual machines. RemoteFX, Windows Server 2012 R2 Hyper-V. RemoteFX allows for an enhanced user experience for RemoteFX desktops by providing a 3D virtual adapter, intelligent codecs, and the ability to redirect USB devices in virtual machines. Fibre Channel. The virtual Fibre Channel feature allows you to connect to the Fibre Channel storage unit from within the virtual machine. Virtual Fibre Channel allows an administrator to use their existing Fibre Channel to support virtualized workloads. Hyper-V users have the ability to use Fibre Channel Storage Area Networks (SANs) to virtualize the workloads that require direct access to SAN logical unit numbers, LUNs, I suppose. Enhanced session mode enhances the interactive session of the virtual machine connection for Hyper-V administrators who want to connect to their virtual desktops. It gives administrators the same functionality as a remote desktop connection when the administrator is interacting with a virtual machine. In previous versions of Hyper-V, the virtual machine connection gave you limited functionality while you connected to the virtual machine screen, keyboard, and mouse. An administrator could use an RDP connection to get full redirection abilities, but that would require a network connection to the virtual machine host. Enhanced session mode gives administrators the following benefits for local redirection: display audio printers, clipboards, smart cards, drives, USB devices, supported plug-and-play devices, shared virtual hard disk. Windows Server 2012 R2 Hyper-V has a new feature called Shared Virtual Hard Disk. Shared Virtual Hard Disk allows an administrator to cluster virtual machines by using shared virtual hard disk (VHDX) files. Shared virtual hard disks allow an administrator to build high availability infrastructure, which is important if you are setting up either a private cloud or a cloud-hosted environment for managing large workloads. Shared virtual hard disks allow two or more virtual machines to access the same virtual hard disk (VHDX) file. Automatic Virtual Machine Activation (AVMA) is a new feature that allows administrators to install virtual machines on a properly activated Windows Server 2012 R2 system without the need to manage individual project keys for each virtual machine. When using AVMA, virtual machines get bound to the licensed Hyper-V server as soon as the virtual machine starts. Network isolation. One nice feature of using Microsoft Hyper-V network virtualization is the ability of Hyper-V to keep virtual networks isolated from the physical network infrastructure of the hosted system. Because administrators can set up Hyper-V software-defined virtualization policies, you are no longer limited by the IP address assignment or VLAN isolation requirements of the physical network. Hyper-V allows for the built-in network isolation to keep the virtual network separated from the virtual network. Dynamic memory is a feature of Hyper-V that allows it to balance memory automatically among running virtual machines. Dynamic memory allows Hyper-V to adjust the amount of memory available to the virtual machines in response to the needs of the virtual machines. It is currently available for Hyper-V in Windows Server 2012 R2. Supported guest operating systems. The following guest operating systems have been successfully tested on Hyper-V and are hypervisor aware. Table 9.1 shows all of the guest server operating systems and the maximum number of virtual processors. Table 9.2 shows all of the guest client operating systems and the maximum number of virtual processors. So here we see Windows Server 2012, Windows Server 2012 R2, Windows Server 2008 R2 with Service Pack 1, Windows Server 2008 R2, Windows Server 2008 with Service Pack 2, Windows Home Server 2011, Windows Small Business Server 2011, Windows Server 2003 R2 Service Pack 1, Windows Server 2003 with Service Pack 2. Guest operating system, Red Hat Linux 5.7, 5.8, Red Hat Linux 6.06.3, SUSE Linux Enterprise Server 11 SP2, OpenSUSE 12.1, Ubuntu 12.04. Windows 8, Windows 7 Service Pack 1, Windows 7 Windows Vista with Service Pack 2 SP2, Windows XP Service Pack 3 SP3, Windows XP XP64 Edition Service Pack 2 CentOS 507, 508, CentOS 6.0, 6.3, Red Hat Enterprise Linux 5.7, 5.8, Red Hat Enterprise Linux 6.0, 6.3, SUSE Linux Enterprise Server 11 SP2, OpenSUSE 12.1, Ubuntu 12.04. Hyper-V architecture. This section will provide you with an overview of the Hyper-V architecture. I'll explain the difference between a hypervisor aware and a non-hypervisor aware child partition. So here you can see figure 9.1. As you can see, Hyper-V is based on a new microkernel architecture. Hyper-V provides a virtualization layer called a hypervisor that runs directly on the system hardware. You can see that the hypervisor is similar to what the kernel is to Windows. It is a software layer responsible for the interaction with the core hardware and works in conjunction with an optimized instance of Windows Server 2012 R2 that allows running multiple operating systems on a physical server simultaneously. The Hyper-V architecture consists of the hypervisor and parent and child partitions. The Windows Server 2012 R2 operating system runs in the parent partition, and it delivers the WMI provider for scripting as well as the VM service. Virtual machines each run in their own child partitions. Child partitions do not have direct access to hardware resources. Instead, they have a virtual view of the resources, which are called virtual devices. If you're running a hypervisor operating system like Windows Server 2003, Windows Server 2008, Windows Server 2008 R2, Windows Server 2012 or Windows Server 2000 R2 in a virtual machine, any request to the virtual devices is redirected via the high-speed bus to the devices in the parent partition, which will manage the request. By default, only Windows Server 2008 or 2, Server 2012, and Server 2012 or 2 are hypervisor-aware operating systems. Once you install Hyper-V integration components on an operating system other than Windows Server 2008 or 2 and newer, it'll be hypervisor aware. Microsoft provides a hypervisor adapter to make Linux hypervisor aware, non-hypervisor aware operating systems. For example, Windows NT 4.0 use an emulator to communicate with the Windows hypervisor, which is slower than molasses in the winter. Hyper-V requirements. The following sections will describe the hardware and software requirements for installing the Hyper-V server role. It is important to understand these requirements for obtaining your licensed software as well as for planning the server hardware. When you understand the requirements, you can design and configure a Hyper-V solution that will meet the needs of your applications. So hardware requirements, in addition to the basic requirements for Windows Server 2012 or 2, there are requirements for running Hyper-V server role on a Windows server. They are listed in table 9.3. Requirement area definition: CPU, x64 compatible processor with Intel VT or AMD V technology enabled. Hardware data execution prevention, DEP, specifically Intel XD-bit execute disable U-bit and AMD NX-bit non-execute bit. Sorry, no execute bit, must be available and enabled. Minimum 1.4 gigahertz recommended, 2 gigahertz or faster. Memory, minimum 1 gig of RAM recommended, 2 gig of RAM or greater. Additional RAM is required for running each guest operating system. Maximum 1 TB, which is a terabyte. Hard disk, maximum 8 gig, recommended 20 gig or greater. Additional disk space is needed for each guest operating system. The add roles wizard in Server Manager additionally verifies the hardware requirements. A good starting point is to check your hardware against the Microsoft hardware list to make sure that Windows Server 2012 or 2 supports your hardware. If you try to install Hyper-V server role on a computer that does not meet the CPU requirements, you'll get a warning that looks like figure 9.2. Software requirements. To use virtualization in Windows Server 2012 or 2, you need to consider the basic software requirements for Hyper-V. Hyper-V runs only the following editions of the Windows Server 2012 or 2 operating system: Windows Server 2012 or 2 Standard Edition, Windows Server 2012 or 2 Data Center Edition, Microsoft Hyper-V Server 2012 or 2 Edition. Okay. Hyper-V installation and configuring. The following section explains how to install the Hyper-V role using Server Manager in Windows Server 2012 or 2 full installation mode or the command line mode in Windows Server 2012 or 2 Server Core. We will then take a look at Hyper-V as part of the Server Manager before discussing how to use the Hyper-V Manager. Finally, we'll look at Hyper-V server settings and then cover 2 important areas for Hyper-V: virtual networks and virtual hard disks. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.